All right, so it was brought up that feedback is probably best sent through AP Classroom, so I'm going to post this solution guide as a link. Please let me know if this as a method works out well, or if it doesn't. Please let me know, because I would love to hear and make this as straightforward for you as I possibly can. So here's the free response that I just returned the grades for most of you on. We've got a function here defined by a power series x to the n for all real numbers for which the series converges. So the first thing is to find the radius of convergence, and this was definitely the one that I saw you all do the best on. Most of you used the ratio test, which I think is exactly right. So when you take that limit and you plug everything in, you can do a lot of canceling out. All these 5s, leaving behind just 1, all these x's, leaving behind just 1, and as n goes to infinity, we can drop these terms, and then it's just n over n. Sorry about that. And then the n terms will also cancel out, and we're left with just x here over 5. And the absolute value of that is less than 1. Multiply by 5, and it says that x has to be in between, absolute value of x has to be less than 5. And if you remember correctly, this then is just the radius. Some of you wrote it as the interval. So some of you wrote negative 5x and then 5, which is fine. You do want to, if it asks for the interval, make sure you're showing work of testing those endpoints. But since it's just asking for the radius of convergence, you can just write 5 as your answer, and that's just fine. All right, looking at part B, write the first 3 terms of the power series to approximate the value of f of negative 2. So what they're just asking you to do is expand this out for the first 3 terms. So you've got your n equals 1 term, n equals 2, and n equals 3. So these are your first 3 terms, and here we just see that we're using x is equal to negative 2, so we can plug that in, and from there it's just a calculator problem. 2 times negative 2 over 25 plus 2 times negative 2 squared over 125 plus 4 negative 2 to the third over 625, which is equal to negative 72 over 625. And obviously, for those of you who use decimal, that's just fine. Now, the next thing they ask is use the alternating series error bound to show that f of negative 2 cannot equal negative 2/5. So you'll notice we had negative, positive, negative, and so then our next term, since it's an alternating series, our next term, which would be n equals 4, is going to be greater than the error that we're going to see. So if we plug this in, we get 16 over 625. And so what that means is that if I add these two together here, that's going to surpass the actual summation of the infinite series. So when we add these together, we end up with a number that's less than negative 2/25, which is why that's not in the range of our error, so that's why. Okay, on to part C. Let g be the function satisfying g of 0 equals 3, and then g prime is equal to f of x. Write the first 3 non-zero terms and add the general term of the power series. So this is one of those problems that builds on part B. So I want us to recall from part B, they asked for the first 3 terms there. We're going to do similar things here. So if that's f of x, if I want to find g here, this is g, the first derivative. So if I want to find g, I take the integral of both sides. So then G of x is equal to, I'm going to put the constant out in front because this is an infinite series, and then 2/25 x squared over 2, because we're just doing a polynomial here. So here's your constant, and then here's the integral of that term, plus 3 over 125 x cubed over 3 plus 4 over 625 x to the 4th over 4, and so on. And then if we did plug in 0 for all these x's, that means that c is equal to 3. So then the first 3 terms would be 3 there. We've got the 2's canceling the 3's and so on. So the first 3 non-zero terms are x squared over 25 and x cubed over 125. And if I wanted to write the general term, that would be x to the n over 5 to the n, or something similar. I think they have n minus 1 because they're starting at squared as this here. But that's not something I'm particularly worried about. Alright, D was just a little one-pointer. It's mostly like, here's a weird hard question, see if you can do it or not. So what it asks for here is using your function g in part C. Using that, find g of -2 or explain why it doesn't exist. So there's a couple different ways to do it. I think that the easiest way is to recognize that this is 3 plus a series. Notice that the series is starting at 2. And I'm going to write this, instead of as x over a power, I'm going to put it in parentheses. And you'll hopefully notice that these two things are equivalent, and that we're just starting at 2 because that's our first term here. The next thing I'd hope that you notice is that this is a geometric series. Now, the only thing that's a little bit weird here is that if you remember, in order to use our geometric series, we want the first exponent to begin with 0. So what I would do from there is, instead of being x over 5 to the n, I would want it to be n minus 2, factoring out an x squared over 25 for the series, and now it fits exactly into our formula, because what we're going to do next is, in place of x, we're going to plug in a -2. So then it becomes 3 plus 4 over 25, because that's -2 squared, -2 over 5 to the n minus 2, and then we can plug that into the a over 1 minus r, like so, and do a little bit of evaluation on our calculator. And so you could write the correct answer here as just a mixed number, 3 and 4/35, or you could have 109/35, both would be fine. There's a decimal answer as well. So hopefully attaching this as a link to the feedback on AP Classroom makes it more accessible. Please let me know how this works out for you. And I'll be around on Zoom and everything tomorrow.